right, so on 53, it has to do with the triangle inequality. And to map this thing out, we're saying that we have two sides of a triangle. We have AB, and we have BC. There we go, C. And we're trying to figure out what the two possible side lengths are between what two numbers should that third side AC be. So if we had this with numbers, let's say we call this one X, and we call this, I don't know, let's pick some numbers like this one is a 5 and this one is a 7. Then, like, what was the shortcut to be able to figure out between what two numbers X could be? All right, add them together, and that's 12. So X has to be less than 12. And then subtract them, and I get X has to be bigger than 2. Compound inequality between X is between 2 and 12. So it's that same technique that we're doing, except for we're doing it with segment lengths. So that 2 came from subtracting, and the 12 came from adding. Now, I think the wording in here is just a little bit off. I meant to fix it. Let's say the smallest possible segment, RS, where, let's say, RS is, now this should be the largest. Okay, because if we were trying to draw the smallest possible for RS is equivalent to, like, the 2 side. Then, like, we could just keep making it smaller and smaller and smaller. But we want the largest possible value that I'd put over here, which would be 2. And the other one should have been, and the smallest possible for PQ. PQ is on the big side there, smallest. Okay, so in order to get, let's say, the small side, I'm just going to subtract these two segment lengths. To get the big side, we're going to add them. To subtract them, we've done something like this in here before. You draw this segment BC one direction, and then you go back in the opposite direction to subtract that off. So let's try that on here. We need to, well, what number was this? 53. There we go. Start with making two segments. Okay. So I'm going to put, this is going to be on the small side. And on the small side, that segment was called RS. So I'll put an endpoint here with an R. And I'm going to first stretch my compass from the length B to C, because I had to take the big one and then I'm going to subtract the small one from it. So I'll set my compass to the radius length from B to C, point on B, pencil goes to C, like so. And let's transfer that onto the purple paper. There we go. Okay, so far right here we have the length BC. And now I'm going to subtract off AB by going in the opposite direction here. So I'll set my compass length now to AB. Point on A, pencil on B. This should do it. And now start where we ended the last one and go back in the opposite direction. And make yourself a mark. So this portion here from the last end point backwards towards the left, that is AB. AB, yeah. So this point here is RS. Maybe I'll highlight this so it's a little clearer, because the stuff that we want is in between these 2 points only.
Screwdriver, so I can type my compass.
Yeah, I'll look in just a second.
Thank you.
Okay, so there's that part. And then the second part, instead of subtracting them, like to get the 12 that was over here, we're just going to add these two pieces. We just put them, like we join them adjacently, one on top of the other one. Now, what was the compass setting that I already had? What was the last one that I just used? AB. So I might as well use AB already. So this segment was called PQ. I'll put an endpoint at P here. Put the point on P. Pencil will make a mark. So this portion of it right now is AB. Now stretch my compass again from B to C. And begin where we ended, and then make our new mark here from this last endpoint, the one that's sort of in the middle, to the last one. That one is our BC. Both of them put together is PQ, and I'll highlight that again in red to make it obvious what part of that segment is my answer. There we go. So this one was the large side. P, Q, the end.